Hi, in this video we're going to look at some special right triangles. So we're going to use some things we know about right triangles to look at two specific examples of special triangles, a 45-45-90 triangle and a 30-60-90 triangle. Okay? We're going to start with the 45-45-90 triangle. Because I know those two angles are 45 degrees, I know the opposite sides are also congruent because of the isosceles triangle theorem. And this is a right triangle because that third angle is 90 degrees. So I have an isosceles right triangle, what we commonly refer to as a 45-45-90 triangle, because that's the measure of its degrees. If I want to look at this 45-45-90 triangle, if I label those two legs of my right triangle x, I can use the Pythagorean theorem to find the hypotenuse. X squared plus x squared equals h squared. So I want to simplify that. What if I want just h? So not h squared, just the hypotenuse by itself. So we're just going to take this equation and we're going to simplify it. So I'm going to add my two x squareds together. And then to get h by itself, I'm going to take the square root of both sides. Because we're talking about lengths here, we only want the positive square root. So h equals, I'm going to simplify this square root here, square root of 2 times x, or x root 2 equals h. So the relationship between a leg and a hypotenuse is that if I take the leg value times the square root of 2, that will give me my hypotenuse length. Okay? We can see where that derives from the formula for Pythagorean theorem. So this is a special relationship that only happens in a 45-45-90 triangle, but it helps us out in a lot of ways. Let's look at some examples where we can use this. We're going to start with a really easy one. In this isosceles right triangle, AB is 10 feet. What is the length of AC? So we could do the math here to show how this works. So I could start with this side being AB. Since it's an isosceles triangle, that means this side over here is also 10 feet. And we could do like we just did and use the Pythagorean theorem. I'm going to call this h over here. So I have 10 squared, which is 100, plus another 10 squared, so 200 equals h squared. If I simplify that, I get square root of 200 equals h. So 10 root 2 equals h. Notice it's the same as side times root 2. So 10 root 2. You don't have to show your work every time when you do these questions. If you know that, if you memorize that relationship, then you can just use it. You can just pull out the answer. So let's do another example. Example 2. From the intersection of Highway 12 and County Road F, a person walks due south 4 kilometers, then turns 90 degrees and walks due east an equal distance along a straight line path. How many kilometers is the person from the original intersection? So we can draw ourselves a picture here. Here's an intersection. Okay. They walk due south 4 kilometers, make a 90-degree turn, and walk east an equal distance. That equal distance being 4 kilometers. So how far are they from where they started? How far is this distance here? So what we have is an isosceles right triangle where my side length is 4. So this is what we have. So the length of the hypotenuse is, if we remember that relationship, 4 root 2. So that's our answer. You don't have to really do any more work than that. If you memorize that relationship, then that's all you have to know. Our next example is a little bit trickier because we have to find out that side length from some other information. The diagonal of the smaller square is the same length as the side of a larger square, as shown in this slightly off but still pretty good picture right here. Pretend like those corners here and here are all matched up together. The area of the smaller square is 36 square centimeters. What is the area of the larger square in square centimeters? So I'm starting with area of the smaller square is 36. So if I know area is 36, then I need to figure out what is my side length. That's how I'm going to be able to find some information here. So if my area is 36, I can find area by doing side squared for a square, right? Side times side equals area. So if those two are equal, then my side is 6. So I can replace these side lengths here with 6. And then I could use that length to find this measurement here, the side length of my big square, which is 6 root 2. And then the area of my big square, since it's a square, all of my sides are 6 root 2. So I can take 6 root 2 and square it. 36 times 2, which is 72. Now, there is a sort of a shortcut here. We have to know a little bit about squares in this relationship. But if this diagonal here, in the middle of my small square, okay, if that is made up of this, the diagonal of this small square is the side length of my big square, then this little triangle right here, the part that's inside my big square, is going to be 1/4 of my big square. So I can check my work here by doing half of the area of the little square, and that would be this triangle here, 18, times 4, which is 72 also. So there's kind of a shortcut to this particular question, but if you're asked to use trig, so if it was not a multiple choice and you were asked to use some trig, you would need to show this 6 root 2 for the side length. Okay? So those are some examples that are multiple choice. Let's find the side length now. What if I know the hypotenuse? How do I find the side length? So this one's a little bit trickier because we have to use our equation backwards. So remember that my hypotenuse is root 2 times my leg of my isosceles triangle. Okay. So if that's true, then I can plug in what I know, which is that my hypotenuse is 8. And then I can solve for the leg. So my leg length is 8 divided by root 2. But remember, we don't like square roots in our denominator. We want to rationalize that denominator. So I multiply both my numerator and denominator by root 2. And I get 8 root 2 over 2. And I can simplify this to 4 root 2. So know how to work your equation backwards so that you can find a length of a leg when you're given the length of the hypotenuse. Okay? So that's it for the 45, 45, 90 triangle. All you really have to memorize is the relationship length of the leg times root 2 equals length of the hypotenuse. Okay. Now, just like 45, 45, 90 triangle, we also have a relationship, a very special relationship between the side lengths of a 30, 60, 90 triangle. So here is that 30, 60, 90 triangle, and we have this written out as a theorem, which reads, in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. So when we look at this triangle, we're always relating everything to the shortest leg. Okay, so let me first point out where is the shortest leg. Well, if I look at my angles, my smallest angle is this 30-degree angle. right? I have 30, 60, and 90. So my shortest angle is 30. And so my shortest side is across from that. So the shortest side length is across from the shortest angle. The largest side length is across from the largest angle. So my longest side is my hypotenuse, which is across from my largest angle, 90 degrees. My shortest side is across from my smallest angle. So my shortest side is always opposite my 30-degree angle. It's very important we know which side that is, okay? So we've got our smallest angle 30 degrees, our shortest side x. If I know that shortest side, 2 times that shortest side is my hypotenuse, and root 3 times that shortest side is my other leg, okay? So let's look at an example of that. Here is a triangle. Notice we have a 30 degree and a 90 degree, so this one has to be 60. Find the values of x and y. So if I start with my shortest side, this would be my shortest side. Okay, so my short leg times 2 equals my hypotenuse. So my short leg is 6 times 2 equals my hypotenuse, which in this case is x. So x equals 12. Use our same relationship to find our longer leg. Long leg times root 3, short leg times root 3 equals long leg. Got that out of order. So my short leg is 6 times root 3 equals my long leg y. I can't simplify 6 root 3, so we just leave it 6 root 3. And that's all we have to do. So know this relationship and use those two formulas right there. Okay. So let me use a different example. What if I have this triangle? This triangle, I am given my hypotenuse. My hypotenuse equals 2 times my shortest leg, which in this case is x, because it's across from my 30-degree angle. So if my hypotenuse is 13, my shortest leg is 6.5. And so then I can use that 6.5 times my relationship here, which is root 3, to get my longer leg. And to get my longer leg, again, I can't really simplify this. I do want to rewrite it though. I don't like that decimal with my root here, so I'm going to make it 6 root 3 over, not 6, 13 root 3 over 2. Change that 6.5 to 13 halves and make it 13 root 3 over 2. And again, it depends on what your teacher would like as an answer. If your teacher wants only fractions, then you would give them x as 13 halves instead of 6.5. If they're okay with decimals, then 6.5 would be fine there. All right? So in short, what you need to remember are these two relationships right here. In a 45, 45, 90 triangle, your short side leg length times root 2 gives you your hypotenuse. In a 30, 60, 90 triangle, your shortest leg, which is across from your 30-degree angle, if you multiply that times 2, you get your hypotenuse, and times root 3, you get your longer leg. And then you can use that relationship to go back and forth between all of the different parts.